Section 3.2.46-T. The data set below on the left represents the annual rate of return in percent of 8 randomly sampled bond mutual funds. And the data set below on the right here represents the annual rate of return in percent of 8 randomly sampled stock mutual funds. We're going to use this information in a table to complete parts A through D and then complete part E. Now for part A, it says determine the mean and standard deviation of each data set. So let's go ahead and we're going to open this up in StatCrunch. Again, sometimes you have to do it a couple times to make sure it gets the data. So now what we want to do is we want to find the mean and the standard deviation of both. So we're going to go and select summary stats and then columns, and then we can go back and let's go back and then just rename the first column to be bond mutual funds and stock mutual funds. Now the reason why I do this is because when you do your project, you want to make sure that you can at least title the columns when you're going through that. So we've done that. So now when we come back to summary stats and then columns, we can now see the names up here. Okay. And so again, we want to be able to find the mean and the standard deviation of both. So let's go ahead and compute. Copy this data. And then we're going to match and see what we get here. So let's see here. We get the mean for the bond mutual funds, rounded to 3 decimal places, is 2.413, which is what we get over here. And then the standard deviation for the bond mutual funds ends up rounding it to 3 decimal places, which becomes 0.720. And there is our standard deviation. Okay, and then for the stock mutual funds, we can see that the mean is 8.275, which is what we get here. And we can see that the standard deviation is 1.081, and that's what we get here for our standard deviation. Now, based only on the standard deviation, it says which data set has more spread. Well, we can see that the bond mutual funds has a standard deviation of 0.720. And we can see that for the stock mutual funds, we have a standard deviation of 1.081. Therefore, based on the standard deviation, we can say that the stock mutual funds have more spread because it has a larger standard deviation. Okay, now the next thing we want to do is we want to be able to find out, okay, what proportion of the bond mutual funds are within one standard deviation of the mean. So we want to find the interval. So we need to find our mean for the bond mutual funds. Well, the mean for our bond mutual funds was 2.413. So recall that for our bond, we had a mean of 2.413. Okay? And then what we want to do is we're going to subtract one standard deviation and add one standard deviation. So recall up here, 0.720 is the standard deviation. So we're going to subtract 0.720 and we're going to add 0.720. And so what we're going to end up getting is this interval right here. So when we take 2.143 minus 0.720, we get 1.693. And then we take 2.413 plus 0.720, and that gives us 3.133. So now what we want to do is we want to look at this interval and then take a look at the bond mutual funds that we have in our data set. Well, let's take a look. We know that we have this interval, and we got to find out all the numbers in this interval that we have here. So what we can say is that 1.693 between 3.133, we can say that 1.7 is in that interval because it's in between those two numbers. We can say that 2.6 is in between those two numbers. We can say that 2.3 is in between those two numbers. We can say that 3.2 is not because it's larger than 3.133. We can say that 1.2, is that in there? Nope, because that means it's less than 1.6, so we can't include 1.2. Can we include 3.4? No, because it's above the interval. We can say that 2.4 is in that interval, and we can say that 2.5 is in that interval. So what do we need to do next? We want to find out what is the proportion of this, meaning that the proportion of the numbers that fall within that interval. Well, how many do we have? Well, we can see that there's 5 that are in the interval and out of 8. So finding that decimal place is going to give us let's see here, we're going to take 5 and then divide that by 8, and that gives us 0.625. So the proportion is 0.625. Okay? So now what we want to do is we want to find out what is the proportion of the stock mutual funds. So again, what we did from the beginning here is we found the proportion of the bond mutual funds. So now we're going to focus on the stock mutual funds. Okay, so we need to first figure out, okay, what is the mean? Well, the mean is 8.275. So we're going to take 8.275, okay, and then we're going to subtract 1 standard deviation because we're going within 1 standard deviation. So we're going to subtract 1.081 from 8.275, which gives us 7.194. And then we're going to add 1.81 to 8.275 to give us 9.356. And so now what we want to do is we want to take a look now at our stock mutual funds and then figure out all the mutual funds that fall within this interval. So if we take a look at 7.0, it is below 7.1, so we can't include 7.0. But 7.8 falls within that interval. 6.6 does not fall within this interval, but 8.4 does. 9.1 also falls within this interval. 9.6 does not. 8.4 falls within that interval, and so does 9.3. So now what we can say is we know that there's a total of 8 stock mutual funds, and how many fell within that interval is 5, so very similar to the one previous. So when we find the decimal of that equivalent, it gives us 0.625. So that represents the proportion of the stock mutual funds that are within 1 standard deviation of the mean. Now in Part D, we want to find the coefficient of variation, which is abbreviated as CV. It is defined as the ratio of the standard deviation to the mean of a data set. So here's the formula, standard deviation divided by mean. So the coefficient of variation allows for a comparison in spread by describing the amount of spread per unit mean. So we're going to compute the coefficient of variation for both data sets. So what is the coefficient of variation of the data set for bond mutual funds? So remember here that the bond mutual funds has a sample mean of 2.413, and it has a sample standard deviation of 0.720. So if we take our formula and take 0.720 and divide it by 2.413, we get a coefficient of variation for the bond mutual funds to be 0.298. Then we look at our stock mutual funds. We have a sample mean of 8.275. We have a sample standard deviation of 1.081. So again, to find the coefficient of variation, we're going to take the standard deviation, which is 1.081, and divide it by 8.275, which is the sample mean, and we get approximately 0.131 for the coefficient of variation. So based on the coefficient of variation, the bond mutual funds have more spread because you can see that this number is larger than this number. Okay, now in Part E, it says in the table below, or to the right here, it says the data set on the left has the heights of students measured in inches, while the data set on the right has the same students' heights measured in centimeters. Now for each data set, we want to determine the mean and the standard deviation, and then we're going to draw a conclusion about the spread using the standard deviation, and then find the coefficient of variation for both sets. So within your problem, okay, what you're going to have is you're going to have a data set to open up. Okay, in this data set you're going to open up, so we have a new data set that we want to open up. So we're going to open this up in StatCrunch. Okay, so let's go ahead and title this. So the first title is the height in inches. And then the next column, we have the height in centimeters. Okay? And so what we want to be able to do is, the question is asking us to find the sample mean and the sample standard deviation. So let's go ahead and do that. So again, we're going to follow the same pattern that we did earlier. We're going to go to Summary Stats and then go to Columns. We're going to select both height in inches and height in centimeters. And then we're going to look for the mean and the standard deviation. So let's go ahead and select Compute. And then we're going to copy our set. Okay, so let's take a look at the data. All right, so we can say now that the height in inches, we have a sample mean of 69.25. And then we have a sample standard deviation rounded to 3 decimal places to be 5.148. Okay, and then the height in centimeters, we can see that we get a mean of 1.7895, and we can see that our sample standard deviation is 13.075. And so what we're going to do is we take the standard deviation, which is 5.148, and then we divide it by the sample mean, which is 69.25, and that gives us the coefficient of variation of 0.074. And then likewise over here, we're going to take the standard deviation, which is 13.075, and we're going to divide that by the sample mean, which is 175.895, and that gives us the coefficient of variation, which is 0.074. So therefore, when we're converting units going from inches to centimeters and units of measure, the coefficient of variation is unchanged. So it was unchanged in either situation because, again, it didn't matter whether you convert it from inches or centimeters.